right, so we're dealing with systems of equations. We're going to be using the graphing calculator a fair bit today in order to solve these systems. There are other ways to solve it other than the calculator. So if your calculator dies, you can solve it other ways. Ways that you learned in Algebra 1 and Algebra 2. But we're going to focus mainly on how does the graphing calculator help us to solve these. And don't worry, that's not you yet. We'll get there. So let me get rid of that. All right. So a second. All right. Let's start with the three possible outcomes for any system of equations, no matter how large or how many variables. For any linear system of equations, there are three possibilities. The best case scenario is that there's one solution. That's the most common scenario in a math class, is that there's exactly one solution. If it's a two-variable system, there's one ordered pair. If it's a three-variable system, there's one ordered triple. Okay, so with that, one solution is also called consistent and independent. Consistent means it has answers. Independent means it has one answer. Okay, so that's those mathy words. You're going to hear me say one solution, infinite many solutions, no solution, but know these words as well. Okay, infinitely many solutions means if they're lines, if you graph them, they lie right on top of each other. Okay, that is called consistent and dependent. Consistent meaning you have answers. Dependent meaning wherever the one line goes, the other one goes with it. They're right on top of each other. So they're dependent upon one another. Okay. No solution means the lines, if it's a linear system with just lines, the lines don't cross, they're parallel. Okay. No solution, it's also called inconsistent. Consistent means it has answers. No answers would be inconsistent. So those are the mathy words that go with that. Okay, so know that for sure, because that's going to be, what we got to find out here from our particular systems that we're going to deal with. So let's get into some examples. And we want to solve. Let's get this one. 2x plus y equals 5. Negative 4x plus 6y equals negative 2. There's a system of equations. In Algebra 1, we work these, and we have the possibility of using methods like substitution or elimination to solve that. Where, if we want to do substitution, we could solve this first equation for y, and then take negative 2x plus 5 and put it in the place of y in this equation, work it out. Do all that algebra that goes with that. So a lot of work on algebra skills there. Or we could use elimination, multiply the top one by negative 2 or by positive 2 and get 4x plus 2y equals 10. And the x's would eliminate and you get an equation with y in it. Those things we learned in Algebra 1, did it again in Algebra 2, and then we learned a way to use the graphing calculator to help us. And that way was the augmented matrix. And RREF. Okay, the augmented matrix is the matrix of the coefficients and the solutions to the equations. Notice that our equations are in order. X, y equals a number. They need to be in that standard form. They need to be in that order when you set up your augmented matrix. That matrix that you set up, the first row is all the numbers from the first equation. 2, 1, 5. The second row is the numbers from the second equation. Negative 4, 6, negative 2. That matrix is a 2 by 3. 2 rows, 3 columns. Okay, got to know the size in order to be able to put this into the calculator. Okay. So this is a matrix we're going to enter into our calculator. So we're going to go to the graphing calculator now. We're going to go to the matrix menu. Anybody remember how to get there from Algebra 2? Yeah, second, and that's the X inverse button. Right above it, it says matrix. So this button right here on the left, right underneath the math button. So second, matrix. And we want to go to edit so that we can put a matrix in. So we're going to press over to edit. And I'm going to put mine in matrix A. If yours has something in there already, that's okay. We're going to, whatever size it says, you're going to change it to 2 by 3. 2 rows, 3 columns. And it should resize the, what you're seeing there so that it's the right way. Mine was already a 2 by 3. Taught some of this stuff last night. So then we're going to put in that first equation. 2, 1, 5. And then the second row is -4, 6, and -2. Just type in over the top of whatever number is there, and it'll override it. Okay. Once you get that matrix in there, go back to the regular calculator screen. So second mode to get back to the regular calculator screen. Then we want to have our calculator do some math with that matrix. So we go back to second matrix, go over to math. We're looking for the RREF. That stands for reduced row echelon form. And it's down toward the bottom, so the quickest way is just when you hit second matrix, press over to the math button and press the up arrow to get down to the bottom the quickest. So RREF is what we want to pick. Don't pick REF because it's not going to do as much as you need. You want RREF. Okay. Hit enter, and then we need to tell it what to do that with. So we're going to pick the matrix we put it in to. So second matrix, and this is where you're under the names menu. Whichever one you put that into, pick that one. So I put it in A, so I'm going to pick A. And then just hit enter. And it cranks out this matrix. 1, 0, 2, 0, 1, 1. Okay. That matrix, after RREF, get this. 1, 0, 2, 0, 1, 1. What that tells us is that, remember we had 3 columns. The first column is X's. The second column is Y's. The third column is the answers. Okay? 1X plus no Y's is equal to 2. That tells us X equals 2. This one says no X's, 1 Y equals 1. So we get an ordered pair out of that. 2, 1. It'll always be in that order, though. If you do use RREF, X will be on top, Y will be on the bottom. If there is a solution. Okay. Easy stuff. Let's do another one. Let's say we had 2X plus 3Y equals 1, and Y equals X minus 3. What's wrong with this one? If we're going to use that method, what's wrong with this one?
2 different formats.
Yeah, not in the right format, right? So the first one, we got it in standard form. We got X, Y number. Second one, not that way. So what do we need to do?
Subtract it.
All right. So move the X by subtraction to both sides. So that's going to give us the top equation is the same. Second equation now is -X plus Y equals -3. Okay. They in the right format now? What matrix are we entering? 2 by 3. That the first row is what? Second row? Good job. So enter that matrix. Make sure when you put that matrix in that you're getting all the numbers right. It's matrix, doing stuff with matrices, it's kind of like dialing a phone number. If you're 1 digit off anywhere, it'll call a completely different person, right? So you don't want to do that. If you're off by just a negative sign in one of the spots, it will not be anywhere close to the same answer. Okay, so going through that step process again, second matrix, go over to edit. I'm just going to use the one that I used before, the 2 by 3, since it's already the right size. and enter in that matrix. So 2, 3, 1, -1, 1, -3. Make sure you got all your numbers in there the right way. 2, 3, 1, -1, 1, -3. Okay. Now what do I do? Second quit to get back to the regular calculator screen. You can go through to get the RREF, you can hit second matrix over to math and press the up arrow if you want to get to that RREF and pick that. Or you can just press the up arrow until you highlight that one and press enter, and it'll recall that command. Now, this A is the new one that I put in. So this is like a new command. It's going to say, oh, use the A that you got in there now. It doesn't remember what the other one was. So that's maybe a quicker way to get it to do the RREF for you instead of hitting second matrix and going over and get, if you're doing a lot of these in a row. Okay. So there's our matrix, 1, 0, 2, 0, 1, -1. 0, 2, 0, 1, -1. So that gives us an ordered pair solution of 2, -1. Okay. So two systems, linear systems that have one solution. You see what that looks like? Really easy to do. Okay. Look at sample C. Here's our system, 2x plus y equals 5. And let's do 4x minus 8 equals -2y. We could move the 4x by subtraction. That would work. And that would give us that equation in the right form. We just need to flip it around. So that gives us -4x minus 2y equals -8. Top one doesn't need to change. So I just moved this over here and then flipped it around so that the x and the y are on the left and the number on the right. Is it ready? All right. That thing in the matrix. 2, 1, 5, -4, -2, -8. RREF. Second matrix. Edit. Use the same one again. 2, 1, 5, -4, -2, -8. Make sure that's right. It is. Second matrix, math, RREF. Second matrix, A. Get 1.5, 0, and 0, 0, 1. All right, that looks different. That is not the same as the other two. What does this line say? I'm going back to what I said when I was talking about the equations. If I pulled this back out of the matrix and made an equation out of it, it'd be 1x plus 0.5y is equal to 0. What would this one be? 0x plus equals, what's 0x? 0 times x, no matter what x is what? 0 times y. 0. 0 plus 0 is 0 over 1. So this line right here tells us that that is a no solution problem. Because the bottom line, the bottom row is always going to tell you what's going on. That bottom row, because it's zeros and then a number over here. It doesn't always have to be 1. It may be a different number, but it's 0 plus 0 equals something other than 0. That tells us that this is no solution. Okay. It would have been infinitely many solutions. We'll see one of those in just a second. So the bottom row, if you've got 0 and then a 1 and then a number, you got an answer. If you've got zeros and then a number over here, that's no solution. And as Christian said, what if that's all zeros? That's an infinitely many solutions scenario. Okay, if it's all zeros, because 0 does equal 0 always, right? So that's where it would be no or infinitely many solutions. Let's look at one that does that and kind of get an idea what that feels like when you get that done. 2x plus y equals 4. Negative 3y minus 6x equals negative 12. This one like this is very commonly messed up. What's the mistake?
The y and
the y and the x in the wrong place. It looks like it's ready. A lot of times folks just jump the gun and put that in the matrix, and it's not the right order. So when you put that in the right order, that second one becomes negative 6x minus 3y is negative 12. 2, 1, 4. Matrix 2, 1, 4. Negative 6, negative 3, negative 12. And the magic of RREF. Second matrix, edit 2 by 3. 2, 1, 4. Negative 6, negative 3, negative 12. And I'm just going to do the shortcut here, RREF on matrix A. Now that bottom row there, we've got all zeros. 1, 0.5, 2, 0, 0, 0. That bottom row tells us that this is infinitely many solutions. Okay. Now, in Algebra 1, and probably in Algebra 2, we stopped there. This is not Algebra 1 and Algebra 2, it's college algebra. We're going to do a little bit more. We're going to write the answers in the form of one of the variables. Okay? So, or better yet, let me reword that. In terms of, that's the best way to say it. In terms of y. Okay. If we're going to write the answers in terms of y, that means we're going to write an ordered pair that only has y. May have some other numbers in there, but it's going to have a y in it. It's not going to have an x variable. Okay. So it comes back to this equation here. That equation up there is 1x plus 1/2 y equals 2. And I just changed it out of decimal form because I'd rather work with a fraction. Okay. If I'm going to write that in terms of y, that means I need to know what does x equal. How can I get x by itself? No. I need to subtract the 1/2 y. That gives me 1x, or just x, equals negative 1/2 y plus 2. X is equal to this. So my ordered pair would be negative 1/2 y plus 2. The y coordinate is just going to be y. That's writing it in terms of y. if they ask us to write it in terms of x, again, we're going to use that equation from the top row. X plus 1/2 y equals 2. That means I need to solve this equation for what? For y. So subtract x. So 1/2 y is equal to negative x plus 2. Multiply by 2. Y equals negative 2x plus 4. What does my ordered pair look like? Good job. Perfect. Quiz or test, I'm going to tell you which form to put that in. Okay? Terms of x or terms of y. All right. So two variable systems. We've seen one solution. We've seen no solution. We've seen infinitely many solutions. Or we've seen consistent and independent. We've seen consistent and dependent. And we've also seen no solutions. Okay. Or inconsistent. Okay. All zeros on the bottom is infinitely many solutions. If there's a number in that spot right there, then it's a no solution. Okay. So there's two variable systems. Let's step it up. Three variable system. X plus y minus z equals negative 1. 4x minus 3y plus 2z equals 16. 2x minus 2y minus 3z equals 5. Now, three variable systems were much more complicated to solve without the calculator. You had to take two of the equations at a time and eliminate the same variable from them. So we might take the first one and the second one and eliminate z and get an equation that had x's and y's and numbers. And then we might take the first one and the third one and eliminate z and get another equation that had x's and y's. And then you had to work that system all to get one answer, either x or y. And then you take that and you go back and you get the other variable from the two variable system. And then you get those two answers and you go back to this and you get the other answer from the three variables. Very long process that multiple places to make mistakes. A little easier using the matrix. So is this one in the right order? Kind of extrapolating what we did with the others. You got a column for x's, column for y's, column for z's, column for the numbers, what they're equal to. So what size is the matrix that we're putting in here? It's a 3 by 4. 3 rows, 4 columns. 1, 1, negative 1, negative 1. 4, negative 3, 2, 16, 2, negative 2, negative 3, 5. Okay, so let's put that matrix into our calculator. Edit. I'm just going to stick with matrix A, 3 by 4. 1, 1, negative 1, negative 1. 4, negative 3, 2, 16, 2, negative 2, negative 3, 5. Make sure I got everything right. 1, 1, negative 1, negative 1, 4, negative 3, 2, 16, 2, negative 2, negative 3, 5. Yeah. All right. RREF on that one. All right. and this is the matrix we get back. 1, 0, 0, 2. 0, 1, 0, negative 2, 0, 0, 1, 1. What does that tell us our answers are? What's 2? Okay. There you go. Ordered triple is the way you're going to do that. X, Y, then Z. So 2, negative 2, 1. What these equations create are planes, like flat planes, and that's why they're treated as linear. The best real world example I could give you would be maybe like where this wall meets that wall and it meets the ceiling. It meets in that one little spot in the corner, right, where all three of them meet. So that's what these equations are. They're flat planes. And if there's one solution, it's a corner like that. Okay? So that's what visually is happening here. 3D is very difficult to draw and solve by, you couldn't do it solving by graphing. I don't think you could do it on paper. There's some technology out there that does 3D drawings pretty well, but it's still even hard to see on those. But that's what's happening here. 2D is really easy to draw because it's just lines, but 3D is really hard to draw as far as getting the special one little spot where they meet up. It's hard to do. All right, let's look at another one. Example F. 2x plus y minus z equals negative 2. X plus 2y minus z equals negative 9. X minus 4y plus z equals 1. Okay? Our system in the right order to put into a matrix. Yeah, we're good to go. All right, so put that into a matrix, solve it. One, two, 1, 2, negative 1, negative 9, 1, negative 4, 1, 1. RREF. Notice I got decimals in there. If I wanted to change those to fractions, I hit math, enter. Makes it look a little better. Not as long. You can kind of see. Sometimes when those decimals get, like if there's more than one decimal, you won't be able to see the other column out of that. So a lot of times just change it to fractions and it'll shorten it up for you. But what do we know about this one? Yeah, that bottom row tells us what? No solution. So that bottom row says that there's no solution. You check your numbers. Something's wrong. 2, 1, 1, 2. And you have a negative 1. And the z of the third equation. All right. So no solution. What's the math word for that? Inconsistent. Yeah. So remember that. Sounds smart. Okay, so we had a scenario of one solution. We have a scenario of no solution. guess what the next one is? Okay, so this one's a little, it's bigger, so the work is a little tougher sometimes on the writing the answers. So let's get the answers for this. Just because it has larger numbers here doesn't always mean it's going to be infinite many there. So that thing in the matrix, 1, -1, or -2, -1, 8, 2, -3, 1, 3, 4, -5. Get that matrix in and run our REF on it. -1, -2, -1, 8, 2, -3, 4, -3, 4, -5, +5. Matrix RREF. Matrix. Okay. All right, so running RREF on that, you see that bottom row, all zeros all the way across. That tells us it's infinitely many solutions, or consistent and dependent. Okay, so that snapshot of that. Yes. All right, so that row tells us that it's infinitely many solutions. So we would write infinitely many solutions. I'll let you abbreviate that IMS if you want to. Okay. You don't have to write it out all the way. Now, let's get the answers. Let's do in terms of Z. That's usually the simplest way of getting the answers written is in terms of Z, because that gives you what's the equations that we get here. One of the equations would be X, like the first row, 1, 0, 5, 22. 0y plus 5z equals 22. So that's really just X plus 5z equals 22. We want to get that in terms of Z, so that means we need to solve this equation for what? X. We want the answer with Z in it, so we get X by itself. It'll be -5z plus 22, or if you wrote 22 minus 5z, it's the same thing. Okay. So with our ordered triple, there's the X part. We need a Y part. So what's the equation that I build to get the Y part? The second row, right? We got 0 X's plus 1 Y plus 3Z is equal to 7. So that's Y plus 3Z equals 7. If I want that in terms of Z, that means I get what variable by itself? Y. Okay, so real simple subtraction. Y is equal to -3Z plus 7. What do we put in the Z place? Z. And there's our answers in terms of z. Okay. If I ask for another letter, then you would just take these same equations and solve for a different letter. Okay. If I ask for it in terms of x, then you'd get z. You could get z in terms of x. And then, well, you can get from here, if I ask this for this in terms of x, you could get z. You know what z is from this one, so you could get y in terms of x. You know, that. Make a little substitution out of that. I'm normally going to ask for it in terms of z. With 3 variables, terms of z. 2 variables, it really doesn't matter which one I ask for. It's about the same amount of work either way. But with 3 variables, I'm going to ask for it in terms of z. Most of the time. All right. Let's get an application of some 3 variable systems. Remember back in chapter 4, when we were dealing with quadratics and we had the vertex form, the intercept form, and the standard form? We had those problems where they drew a graph and they gave you the vertex and maybe one other point for the, and you have to find the equation of the quadratic. And I had you only do the ones that gave you the vertex and another point. And I said, don't worry about the other 3. There's a better way. Welcome to that better way. Okay. So this is if they get 3 points that are on any quadratic. Okay. You get 3 points that are on a quadratic. Sample H. Take 3 points from a quadratic and create the function using systems of equations. Okay. Now, points on the quadratic are -1, -4, 1, 6, and 3, 0. I need 3 points. The reason I need 3 points is because I'm trying to create this function that's quadratic. What's the standard form for a quadratic? Ax squared plus, let's see, okay? Now, what are these ordered pairs? What are the parts? -1 is a what value? -4 is a y. Look at this equation. We got x's, and f of x is the same thing as what? So we got x's and y's, okay? What we do is we create 3 equations using those ordered pairs, 1 for each ordered pair. So for -1, -4, we're going to plug in the x and the y and create an equation. So it's going to be a times -1 squared plus b times -1 plus c is equal to -4. That creates an equation that has variables a, b, and c. So instead of finding x, y, and z on this type of problem, we're going to find the coefficients of our quadratic, a, b, and c. So this creates, what's -1 squared? 1. So that's 1a minus 1b plus c is equal to -4. We've created an equation using the first ordered pair. Let's create an equation using 1, 6. A times 1 squared, b times 1 plus c equals 6. The equation we have, a plus b plus c equals 6. Last ordered pair is 3, 0. So we got a times 3 squared plus b times 3 plus c is equal to 0. 9a plus 3b plus c equals 0. This is our system of equations that we want to solve. But we're going to solve, that's a 3-variable system. A, B, and C are our variables. Now, we do a system of equations with that. If this makes a quadratic, we find A, B, and C, then we can rewrite it as a function there. Okay? So, matrix 1, -1, 1, -4, 1, 1, 1, 6, 9, 3, 1, 0. Okay. We're going to do RREF with that. Y'all tell me what you get. What that third column ends up being. I got that third column? Down through here, you got 0, 0. What now? The third column. Okay. So this is A, this is B, this is C. All right. So that means our function, f of x, is -2x squared, 5x plus 3. How can I check to make sure that's correct? Graph it. Graphing calculator here. So -2x squared plus 5x plus 3. There's a parabola. That's the right shape, no doubt. We put in a quadratic. But does it go through the right points? So I'm going to check -1, -4. So I'm going to hit trace, -1. Pretty good right there. Check the next one. Check 1. Enter. 1, 6. Good. Not much chance of it missing the third one. 3, 0. Any 3 ordered pairs from a quadratic, you can get the equation through a system of equations. It doesn't matter if one of those points is a vertex and the other 2 are intercepts. It doesn't matter. Any 3 points. They could all 3 points be from the same side, and it's still going to get you the right equation. Using that matrix and system of equations to do that. So there's an application of some systems of equations. You ever seen what's the movie that came out a couple of years ago? Hidden Figures. Where they're launching into space. And they did a lot of those calculations by hand when they first doing that. So the whole story is based around those ladies that did that sort of thing. And they were having to find these trajectories for the space shuttle or what shuttle, the capsules and things. The equations that fit those so that they would know where it's going to land in all systems of equations is how they came up with that. Much larger systems than what we're dealing with here, much more complicated problem. But that's what they were doing, and then they brought in the computer to help do that, and it does that now, but much faster now than it used to be. But pretty neat thing. All right, last thing, performing row operations. Easy thing. This is a non-calculator thing of the sections. Okay. Here's a matrix. Okay. that matrix is close to being solved. And what I'm going to do is I'm going to give you a row operation to do, and we're going to do that row operation, and it'll actually solve this matrix, is what it'll do. But the idea is being able to do the row operation. The row operation we want to do is to take 2 times row 2 plus row 1, changing row 1. Okay, that's how the notation for that. 2 times row 2 plus row 1 equals, and that tells you which one to change. Okay, we're only going to change row 1. Even though we're multiplying 2 times row 2, the end result, row 2 is going to stay the same. Because we're only changing row 1 because it said row 1 is the only thing that changes. Okay, we're going to use row 2 to change row 1. Now, what that tells me then is I need to do what with row 2? Copy it down. Because I'm not changing it. This row operation said change row 1. That's why I'm going to copy down row 2. Row 1 is changing by taking 2 times the corresponding parts in row 2 and then adding it to that same spot in row 1. What's 2 times 0? 0 plus 1? Well, the first row has a 1 right there. 2 times row 2 in the second spot. 2 times 1. 2 plus negative 2. 0. 2 times the third spot in row 2. 6 plus 2. 8. That is our result. Now, the reason I do one like that is because I want you to appreciate what your calculator is doing. When you hit RREF, what it's doing is an algorithm of a bunch of row operations to create a matrix that ends up like that. Whatever it starts with, it does a bunch of row operations in the processor and ends up with a matrix that looks like that. What I want you to be able to do is if I give you a certain row operation to do to a matrix, be able to do that row operation. Okay. Let's do another one that's maybe not as simple. Let's start with this matrix. 2, -4, 9, 5, 3, -7. So there's more numbers in there. Makes it a little bit tougher. And we're going to do 2 row operations. The first one is we're going to take row 1 and change it by doing this. -3 times row 2 plus row 1. After we've done that, we're going to do this one. Row 2 equals 5 times row 1 plus row 2. Okay? They're going to give you multiple of them to do. Do them in order. Okay? Whatever the order they give you them in. So here I give you 2 of them. We're going to do number 1 first, because that makes sense, right? So we'll get the answer for number 1 and then use that to do number 2. And if there were a third one, we would use that answer to do the third one. Okay? So if they give you multiple row operations to do the first one, get that answer. That's your new one to start with for part 2, part 3, and so on. Okay? So for this one, for number 1, which row is changing? Row 1. Okay? So that means I know that row 2 is not changing for this first one. So this is row operation number 1. Okay? What does it say to do? And then add that to row 1. So -3 times 5 be -15 plus 2, -13. So that's what goes there. -3 times 3 plus -4. -13. Okay. -3 times -7. 21 plus 9, 30. So after row operation 1, this is our matrix. And this is the one we're going to use to do operation 2. Scroll that far. Operation 2, which row is changing? Row 2. So I'm going to copy down row 1. Okay. 5 times row 1 plus row 2. 5 times negative 13. Negative 65 plus 5. Negative 60. We already know that's negative 65 plus 3. Negative 62. 5 times 30. 150 plus negative 7. 143, right? That is the end result. And that would be the final answer for that particular problem, because we're done with, we don't have any more row operations to do. If there were a third row operation, you would start with this guy. Go from there. From here in the row operation. So they're going to straight out tell you what to do. You just got to follow directions. Okay. All right. It is 9 o'clock. We're in here until at least 10. You got an hour to start working on stuff for this. Through 79. Sorry. Okay.